My name's Dr. Kevin McCairn. I'm a systems neuroscientist, and I'm a primate physiologist. I would model neurological diseases, and also, back many years ago, as we were trying to understand neuropsychiatric disorders, I was spending a lot of time trying to work out the networks that were responsible for things like OCD, ADHD, that type of thing. So yeah, that's my background. I'm retired now, so I get to speak freely without institutional pressures on me. We just go straight in. I don't know how much the camera is off. Okay, so SARS-CoV-2. We're going to focus specifically on the spike protein. I've given this talk before. This is going to be a very pared down version, and I'm going to state the case that the spike protein, the virus itself, is essentially an engineered prion. I'll explain what prion is in a minute. Incapacitation agent. If you want to get in touch with me, if you have questions, ResearchGate is a good place to follow me. You can DM me from there, and you can see my previous work. It's all publicly available on that site. So I mentioned prions. We need to think a little bit more broad than that with respect to this particular topic, and we need to think about something called amyloids as well. And so this is a very pared down table of what are called amyloidogenic proteins and also the prion proteins. And maybe people essentially, just because of things like mad cow and chronic wasting disease, have maybe heard more about prions. And they were originally discovered in the late 80s, and they were given the designation, the scrapie form, after the disease that occurs in sheep. And what we've come to learn over the decades, as studies have gone into prion disorders, is that we see similar properties and their involvement in my field, particular neurological disorders. And these are things like Alzheimer's disease, where you would see amyloid beta or tau, and Parkinson's disease, alpha-synuclein. And I've just listed in there serum amyloid A, because you do get systemic versions. But this picture is quite fluid, and we're still very much finding out the precise nature of amyloids and prions. And essentially they can be, you can think of them as interchangeable because of a core property, and that is that they shift, all these peptides shift from having a bunch of what are called alpha helices to developing a hydrophobic beta sheet core. And it's this beta sheet core that essentially becomes kind of sticky. And what they do is that they will stick to other proteins. And initially it was thought that only like would go to like proteins, but as we've come to understand amyloids and amyloidogenic peptides more, we're finding that they can trigger amyloid processes in other peptides as well. And so this makes the landscape of these protein misfolding disorders very, very complex. With respect to these symptom subtypes, we can look to specific areas, brain regions, and maybe from the outward appearance have or generate informed hypotheses as to why you would see these particular manifestations, behavioral manifestations. And on the left hand side are just some MRI images I grabbed off. These are from Wikipedia, but these are just MRIs that show that, if I can, maybe I can put a laser, let me do laser pointer. I think the mouse is better. It's here. There we go, laser pointer. So in this particular instance, A and B, what you can see, these lighter areas around which the mouse is moving, that's the chordae and putamen. These are classically part of the basal ganglia. And C, you can see these bright lit areas. These are regions of inflammation in the cortex. And there's the classic hockey stick sign of CJD, which is again inflammation in thalamic regions. Now, prion disorders, the CJD family of disorders, bovine spongiform encephalopathy, chronic wasting disease, they're primarily categorized by their appearance microscopically of it's called bovine spongiform, spongy meaning to look like a brain, and you have lots of little holes in the brain as the tissue dies back. Now, I mentioned earlier that with respect to amyloidogenic and prion, I listed a whole bunch of peptides. What we find, and in this is from a CJD patient, so I took this one from CDC website. You can see here these amoeboid type structures, and this is amyloid. This was one of the, peptides that I listed as what was considered distinct and part of a discrete subset of neurological disorders. And this is what I want to try and sort of hammer home, that again there's a lot of crossover with these types of disorders we're discovering, particularly at these very sort of fundamental and molecular, physiological and anatomical layers. And so with that in mind, within my own discipline, particularly in the last sort of 5 to 10 years, the concept of prion, the proteinaceous infectious particle, has spread to the description of classical neurodegenerative disorders, in this case Alzheimer's, Parkinson's, etc. And the key takeaway here is that below bacteria, viruses, we have these proteins, so orders of magnitude smaller than a virus, and it's the protein peptide sequence that itself that becomes infective, and it essentially causes a cascade to a buildup of these infective proteins, and they will propagate and spread as the disease state progresses. And nowadays we think of all these diseases as all these neurological diseases, Creutzfeldt, Alzheimer's, Parkinson's, there are more, as prion-like disorders. And so I need people to sort of think about this when I'm trying to describe the behavioral sequelae or the effects of this, and how that would impact something like the emergence of long COVID, ME, CFS type disorders. So everyone is probably really tired of seeing this picture of SARS-CoV-2, but I just want to use it to help orientate where and what I'm talking about. So I'm going to primarily focus on the spike protein. I'm going to make the contention that that's, for the sake of this talk, that's where we see the most obvious engineering with respect to its provenance, or epitopes that look suspicious. And I would just put forward the premise right now that if SARS-CoV-2 is the product of, and this is, please go and check, look around, do your own research, but biowarfare never stopped, and its research never stopped in the 70s. We have a very active biowarfare medical countermeasures industry that exploded after excuse the pun, after 9/11, and it's quite likely that SARS-CoV-2 is a consequence of that industry in and of itself, in a best case scenario. I'll leave it to your imagination what the worst would be. And so we're going to focus on the spike protein, and I'm going to point out where the amyloidogenic sequences are and what that would mean with respect to behavioral consequences, short, medium, and long term. So this paper came out recently, just last month, and so people say, well, SARS-CoV-2 is it's not as serious as the first breakout, and people are not suffering with the extreme symptoms, etc. But the neuroinvasive, or what we term neurotropic potential, has been identified as being the same. It doesn't matter what the strain is, and it doesn't matter what the initial symptom expression is either. They'll find, of course, this is in laboratory test platforms, that it's capable of passing the blood-brain barrier and lodging itself into the brain parenchyma. So one of the standout studies that really began to crystallize particularly in my mind, that we were dealing with something particularly dangerous with respect to the spike protein, the virus itself, and also the gene transfection technologies which constitute the vaccination programs, was this study from Nystrom and Hammerstrom. And what they showed very eloquently was that the spike protein is studded with multiple amyloidogenic epitopes. And so if you're unfamiliar with these types of studies, molecular studies, again, as I showed you in the earlier, where I showed you alpha helices turning to beta pleated coils, you can see the same type of diagram, but you're looking at it's a simplified version of the spike protein. And in the bottom row, where you can see these molecular drawings, you can see where I hope it's clear that there are different colored segments on the spike protein. And if we look at well, actually, this is all the spike protein, and what we can see is that there are amyloidogenic epitopes, meaning short sequences of amino acids all the way through the spike protein. Now, well, people ask, well, what's the issue with that? It'll get metabolized, and the immune system will deal with it. And what they were able to show in this study is that, in fact, the immune system challenging the virus, the spike protein, in this particular instance, a enzyme called neutrophil elastase, causes the spike protein to fragment and break out like a cluster munition, and spread these epitopes through the intracellular and extracellular environment. This is particularly concerning, because when we look at SARS relative to the other SARS-like virus, meaning MERS and the original SARS, what they've highlighted here in red is that the sequence for neutrophil elastase to bind onto is significantly longer than the previous iterations of SARS and MERS. And again, I would, in light of the existence of the biowarfare medical countermeasures industry, I would encourage you to be very, very circumspect about the provenance and origin of such a significant change with respect to the molecular structure of SARS in this particular instance. Of course, one of want to change tack a little bit and talk about more different type of amyloid. And one of the first studies to come out with respect to SARS was from Theresia Pistorius in South Africa. And what they were able to show is that within the blood circulation, the exposure to spike protein itself causes the emergence of, again, think about Lego bricks stacking together, sticking together and forming oligomers. And you can, what they found was that these amyloidogenic prion-like structures were resistant to the normal enzymatic degradation mechanisms that the blood uses to control for clots. So already we're seeing a number of unusual, not unusual per se, but a stacking of properties that look, only 5 minutes remaining. I need to run very, very quickly. I've taken too long. But again, we see multiple levels of the emergence of amyloidogenic proteins. And to complicate the issue further, when SARS first emerged, there was a big brouhaha about the inclusion of HIV-like epitopes, and this got jumped on very, very quickly from up on high. They tried to squelch this. This is just a 3D representation of that spike protein. The yellow dots at the top are these HIV-like sequences, and also they're present in something called the furin cleavage site. And what I again want to do, I'll skip that slide, is point out that these peptides, the HIV GP120, is identified as being amyloidogenic as well. Now, concerningly, what we've seen, and just by chance we have this study, was that someone who was due a PET scan for Alzheimer's had received a vaccination the day prior to going into the scanner, and we see the binding of the radio-labeled ligand to amyloid beta in this individual, and we can see it at the injection site and in the lymph node. And again, think about these amyloidogenic peptides sort of building out like a, I don't know, trying to think of appropriate analogy beyond Lego, but just think of them sticking together and forming these very unwieldy protein structures. If we look at the open source sequences of where the amyloidogenic sequences are with respect to the wild type sequence, both the Moderna and Pfizer vaccine have the same distribution, and in fact, codon optimized in this particular case, of these amyloidogenic sequences. And like I say, this is very, very concerning, coupled with the observations of Jean-Claude Perez, Claire Marais-Charmin, and Luc Montagnier, who they found a 260% increase in Creutzfeldt-Jakob and on average, 11-day emergence of what they are calling a new variant Creutzfeldt-Jakob. Now, I want to talk a little bit about excess deaths. Now, the pandemic has been marked by a wave of all-cause mortality, and people would generally think, well, that would be COVID, right? Well, that's not the case. If we look, so this is data from a year ago, and I updated it today. And where do we see the majority of deaths? Well, primarily within the cardiovascular, hypertensive diseases, so think of the microclotting, but also Alzheimer type diseases and dementia type disorders. Now, maybe the all-cause mortality is dropping down, but this is data from the ONS in the UK, and the left-hand side would be the younger generations, and we see particularly this year and last year, a very, very large increase in all-cause mortality in that particular bracket when we shouldn't expect it, and a natural pandemic should have long passed us by. So, of course, there's there are hypotheses now about potential prion involvement in long COVID. The number of papers there, and of course Stephanie Seneff will be presenting today. I want to point to this. Well, you could say that's just hypothesis, but I want to read out this paper, which was published in 2021, and they, well, I'm not going to read it because I'm short of time, but basically they show that the spike protein from SARS-CoV-2 can cause prion-like propagation in this disease model. Well, in final passing, I'd just like to say thank you, Philip, for taking the time to organize this, Joachim as well. Everyone here, it was fascinating listening to you all. To people who are listening, I would just say this one thing. It's highly likely that the reason we ended up in this situation was because of biowarfare, medical countermeasures industries. You need to get active in making sure that they're wound back in. And how that's done, I'm not exactly sure, but we have to at least try. And as Chetty said, have faith that we can prevail in the end.